Hi there and welcome back to the channel. On today's video, we'll be looking at a very simple process called electrolysis, and this time around we'll be using the DWSIM simulation. I've also done a similar exercise whereby we used the electrolysis, but that time around we used Aspen Hysis. On today's example, we will be looking at water electrolysis, but this time around using DWSIM. Before we start the simulation, let us also explore the theoretical knowledge or the background. There are some key elements that play a very crucial role during electrolysis, and we are going to explore them. So the first one is the cathode and the anode electrode. So the cathode and the anode electrode are usually electrodes that we connect to our electrolyte solution, which will also be connected to the battery. What is the cathode? The cathode is where reduction will take place, whereby the gain of electrons will take place at that particular electrode. An anode is an electrode where oxidation reaction will take place, and that includes the loss of electrons. Instead of our electrolyte solution, we are going to connect an anode and the cathode. So the anode will be connected to the positive terminal of the battery, whereby we aim to attract anions, which are basically negatively charged ions. And then we are also going to connect the cathode to the negative terminal of the battery to attract cations, which is the positively charged ions. Let's be practical. Let us look at water. So for example, water is made of hydrogen and oxygen. And this is where now electrolysis come into play. It gives us the ability to separate water into its constituents, and that will include the hydrogen gas and its oxygen gas. Half reactions. Half reactions are basically the reactions that will be taking place inside of our electrolysis process. So our electrolyte solution today includes water, and we are going to connect two electrodes, and that's the cathode and the anode. So remember, the cathode, it's where reduction occurs, the gain of electrons, and the anode is where oxidation occurs, the loss of electrons. So at the anode, we will now see the oxidation process taking place, and that's where we expect to see our water and our oxygen. And then at the cathode, where reduction will be taking place, we expect to see now our hydrogen ions attracting towards that particular electrode. Let us be practical. Let us do now the DWSIM simulation. If you open your DWSIM simulator and you click on create new simulation, it will open up this pop-up. So you'll now have to add your compounds, and that will include water. You'll have to add your hydrogen and also your oxygen. Next up, it's your thermodynamic properties. So let us select the most appropriate or applicable thermodynamic property for this particular exercise. And lastly, you will have to now select your units of operation. In engineering, usually we work with SI units for engineering, but choose the ones that you feel most comfortable with. And then last, those are just some of the few setup options that it asks you that you just need to enable for yourself. Not a must, but you can, it's advantageous, such as redo and undo. And once you're done, now you'll see your simulation popping up. For your simulation, please do add or connect your streams. So we are going to have at least 3 streams that will be our inlet and 2 outlets. So DWSIM already has a built-in water electrolysis option, so you can just click that option there. And in terms of the electrical or power supply, there are some few options there. You can take the wind turbine, but for this exercise, let's just take the most common one, and that's the solar panel. If you're happy, I like by starting with the first stream, and that's our inlet, right? You can number them all, or you can just get straight to the point. So I'm just going to clear everything and specifically say I want pure water entering into my electrolyzer, where the electrolysis process will take place. For the sake of the exercise, let's just give it 10 kilograms per hour. This is just an exercise, guys, and everything will be taking place at room temperature. Once you're happy, please connect all your streams to your electrolyzer. Usually connects this automatically. I don't know why it didn't, but it's okay. I just added there an energy stream connected to the electrolyzer, and where the power source will be coming from. And this time around, it's the solar panel. Also connect your electrolyzer to all the inlet and outlet streams. And then the next step now will be to define your parameters for your electrolyzer. Depending on the power supply, you can just specify there. For now, I just said we're just going to need 24 volts, and the number of cells can just be 1. You can also edit your solar panel depending on the output you wish to get. I solved my simulation, but I also got an error. And based on this error, I'm just going to change my thermodynamic properties. If you solve again, now it should be okay. So you'll see that the top stream of the electrolyzer that you can see there, well, it's not necessarily the top, but one of the stream outlets would have a lot of hydrogen in it, dominating there, and the other stream will have mostly water and oxygen. So you can label your streams accordingly, and also you can also add your property table there, and you can just specify all your properties. It makes life easy. It's not a must, but I usually like seeing everything just there instead of always having to hover around my my streams. Yep, and that's typically it. That's how you can use DWSIM for your water electrolysis reaction process. I really hope this makes sense. If you need anything else, shout out. I'm here for you. Till next time. Bye.